Tonight we've got Dan Jackson along to talk to us about the Southern Cross Austereo or SCASat radio networking system. This is where satellite and terrestrial IP streams cohabit. Australian commercial radio networks rely on sophisticated program networking to deliver the most popular personalities and shows from multiple locations to audiences across the whole of Australia. The SCASat system takes advantage of both satellite delivery and wide area IP networks with audio over IP and modern broadcast playout automation techniques to manage program streams to all stations whilst maximising the live and local feel for listeners. Very nice. Dan joined Southern Cross Austereo or SCA in 2009. He's been Technology Manager for Sydney Operations and then National Radio Engineer and was the Project Engineer for the SCASat project. Dan is presently Head of Audio Operations at Southern Cross Austereo, which includes Triple M and Hit Radio networks. Please welcome Dan Jackson, and I'm interested to hear what he has to say.
Thank you, Graham. Firstly, congrats on the reappointment, Graham, and thank you, Peter, for organising for me to come down. Apologies, I couldn't make it to the June. I had a whole month off of June in the US, so that was a holiday for me, which was very good. Well, I don't think I will ever take a holiday again by the sounds of it. So, as Graham said, my name's Dan Jackson. I'm the Head of Audio Operations at Southern Cross Austereo. I've been with the company for 9 years. I started in the Perth office as an apprentice. I studied electronics and communications. I did further studies after that. But previous to that, I was somewhat of a music teacher in a previous life. I loved electronics. I created guitar pedals. I did everything from etching to drilling to you name it. And that's how I sort of got into the radio field. And really, it's been a pretty much a whirlwind 9 years. I spent 5 years in Perth, and then the last 3 years in Sydney, where I, as Graham mentioned, I looked after the team there. And then fortunately, I sort of stepped into a role which saw me be pretty pivotal in the SCASat system. As you'll see tonight, it's sort of groundbreaking in that when we went to market to look for a solution, we just simply couldn't find one that met both the engineering needs and the content needs. So, which is why we sort of it was a greenfield type approach. I do have to apologise up front. It is a bit of death by PowerPoint. However, I can't take complete credit for this presentation. I have done this presentation a few times, and the slides you'll see tonight were actually created by a gentleman named Kirk Harnack, which I'm sure some of you are familiar with. He's part of the Telos Alliance. In fact, I think I saw a video on your website with him. And if you don't know who he is a news and weather anchor in the US, but he also works for the Telos Alliance. So you'll see the TV and the star swipes and everything sort of come through into the presentation. So I apologise up front for that. So I guess Southern Cross Austereo, if this works, there we go. Southern Cross Austereo, for those who don't know, is one of Australia's largest entertainment media company. We have 78 analogue stations and about 55 digital stations now. We also have a fair amount of TV on the eastern seaboard, which sees us reach about 95% of Australians. Southern Cross Austereo currently employs, from a technology point of view, about 60 radio engineers and TV engineers and about 30 IT engineers. We're pretty fortunate that we are able to have engineering staff within the organisation with specialty skills. So from an IT point of view, we've got network administrators, which are obviously very important in the industry now, given that a lot of our audio is heading to an IP-based world. And we also have TV transmission engineers, audio engineers, and obviously professionals in the IT fields as well. I guess when there is any type of innovation, it generally stems from a problem. And one of the problems we first had at Southern Cross Austereo, I guess, needs a little bit of context, and I guess that requires a little bit of history, and I'll keep it quick. But effectively in 2011, Austereo merged with Southern Cross, which saw Austereo, being a metro-based organisation with around 12 services, suddenly turn into 78. And if we look at what Austereo was using at the time, it was a fairly robust system. It was a WAN-based system with redundant WAN links between all the metro cities. We used a Harris product, a Harris Intraplex, which is like a Eurocard style chassis, which has a bunch of cards of any flavour. We used MPEG-2 for our distribution of our content shows, and we used Aptex for our bidirectional lines between the main capital cities, and they were used for interviews and remote talent and things like that. On the Southern Cross side, we had a bit of a mixture due to various mergers and acquisitions previous to that, where we saw them owned by Macquarie Bank, RG Capital. So we had this they picked up some DMG stations. So, we had a bit of a mix across the country, and their main delivery method was satellite. They had a main uplink on the Gold Coast out of their South Bank studios, and they had a main uplink in Townsville. The process there was pretty manual. When they wanted when a storm came into the Gold Coast, we needed to switch it to Townsville. It was a fairly, on the phone swap over type method. And obviously with satellite technology, it's susceptible to rain, storms, and sun transients, which happen every year. So I guess when the company merged, we ended up with this clustering of network distribution methods, and I think in total about 6. And by the time it got to the far outreaches of southern Western Australia, you had linear audio that almost sounded like AM before it got on the dial. So that was sort of the problem. So we set out to basically create what we think the world's first SAT-WAN parallel audio distribution and contribution network, and that's ultimately what I'm here to talk about tonight. So the main problems we had were legacy systems, duplication and overlap, no integration between the systems. No system knew what the other systems were doing. There were single points of failure everywhere. Most of the equipment was pretty old, especially some of the Starguide equipment. We were still relying on ISDN, and it was analog satellite, so we were sending analog signals over the bird, which is pretty horrible. So here's an example of how bad our encoding and decoding schemes got. So out of Sydney, we'd send 256 MPEG to Melbourne, which would then send 256 re-encoded MPEG-2 to the Gold Coast, which would send it up the bird at 128 MPEG-2, be brought down, go back up as 128 MPEG-2. So by the time it got to some of the stations in WA, as I said, it was fairly horrible. And of course, the system, it was just so many chinks in the chain. It only took one to break, and the whole system would fall over. And yeah, it was pretty horrible. And we dealt with that for a few years, but I think through tried and tested, Steve Adler was able to get it through to the board and say, look, we've got 2 problems here at Southern Cross. One is the way we distribute our content, and the other one is how we play it out. And I'll talk about that a bit later. One of the other issues we had is it only ever was able to handle 2 channels, and the company was growing and the needs were increasing. So we went from effectively 2 channels to what we'll talk about later, but we're at about 18 channels at the moment over the bird. So that's the problem. So that's the problem we had. So I guess we needed to do our due diligence and go to market and find, surely, your Cumuluses and your Sirius radios and your big organisations over in the US and even the BBC would have a solution for us. We went in very technology agnostic. We weren't just going to pick a single vendor and just give, basically change our requirements to suit their infrastructure. So we went out to market, we couldn't find anything. So we put in an RFP, and we only had a sort of couple of high level points in which we wanted to satisfy. We obviously solicited our requirements of content. They were pretty simple. They just wanted more channels, and they wanted it to be easy to use. And that was pretty easy for us. We had a bigger list. Things like we didn't want RS485 or R232. We didn't want contact closures anymore, optos or relays. We wanted to be able to use, the new Fraunhofer codecs, AAC Plus, low delay, HE. We wanted to be able to delay the data on the remote end. So obviously in Australia, in summer, we had up to 5 different time zones. We didn't want to have to duplicate our uplink 5 different times to satisfy the needs of Queensland and WA, etc. So we wanted the data to be delayed on the remote end. And I guess we wanted to give the control back to content. Previously, it was very much an engineering-driven switching type system, which saw engineers basically working on the weekends, swapping all the lines over it. We wanted this to be driven by content. It needed to be easy. And they needed to be able to use this system like it's just part of their job. So I'll show you a bit later, but I think the end result was pretty good. If you know how to use an Outlook calendar, which I think everyone in this room and this century should be able to use, you should be able to use the SCASat system. So we went out to market, and unfortunately, the RS232 and the 485 kind of knocked off most of the vendors pretty quickly. We wanted everything over IP, so we ended up partnering with the Telos Alliance, who provide Axia Audio, which is it's their own IP audio. It's AES 67 compliant now, but the version we use is their own proprietary protocol, and that's really to do with the clocking mechanism they use. It doesn't quite integrate with Dante and Ravina and the flavors of IP audio. AVC, Audio Video Consulting. They're a company based in Melbourne, New Zealand. They've got presence in India, Northern Africa. In fact, Ian Campbell, who's the head of their software, is here tonight. He's decided to drop in. He's based out of Melbourne. And we also partnered with a company in Canada who, Novra is the name of the company. They build satellite encoders and receivers. In fact, I think they've recently acquired, I can't remember, but they're a big satellite organisation. So, as I mentioned before, we had that set of requirements that we needed met. And whilst everyone was able to meet most of the requirements, some of them, it was kind of vaporware for them. They didn't quite have the concept yet. They said they could do it, but it was something that they would have to work on. So straight away, we said, the GPIO, which is our control mechanism, and the audio had to be in the single box. We didn't want one box to do audio and one box to do control. Had to be all in one box. We didn't want 32 boxes in the rack to do 32 channels. We wanted it to be a small footprint because that's the way everything's heading. And we ended up with knocking off a few more vendors. And effectively, we kept going deeper and deeper. And essentially, we kind of got down to the last vendor, which was the Telos Alliance. And what they were able to provide was what we call the Telos iPort, which is there on the left. It's a 2RU fanless box, and it essentially runs on Linux, and it has 16 bidirectional independent encoders and decoders. It also has a solid-state drive, which enables us to delay the data or the audio as it comes in, including the control, and I'll explain why that's important soon. And it's also it's an off-the-shelf product, so we run 2 of these in every one of our markets for redundancy. It's got 2 Ethernet plugs on the back, one for the WAN and one for the Livewire. So we get the encoded audio on one, and it goes back to Livewire in a linear format, even though it's being compressed, on the other. So dual path distribution, I want to talk about that. That was one of our main I guess that was the number one point we brought up with when we went on the RFP. And every RFP came back with satellite as one of those paths. So, and it kind of made sense to us because Southern Cross use satellite, Austereo use WAN. We both love them, but they both have their issues. Spade fade, rain fade, Telstra, need I say more? And we wanted the best of both. So what the iPort is able to do that no other product was really able to do at the time, back in 2012, was it was able to take two streams of the same data and effectively pick packets from each data stream. It was able to offset the WAN data from the satellite data using buffering. So effectively, the satellite could fall out of the sky and it would continue on the Telstra network, or vice versa. Someone could go through the fibre cable in the ditch and we would stay on the air with the satellite. And to this day, we've never, fingers crossed, touch wood, never had the issue of both being down at the same time. But with only one uplink, that still leaves a little bit of lacking of redundancy. So what we ended up doing is we put an uplink in Sydney and Melbourne. And this system is an automatic system, so we have detection methods to work out the attenuation between the Earth station and the satellite. And if we detect if that variance gets too great, it'll automatically switch to the other side. So we have about a 3 dB setting. So if the satellite beacon attenuates by 3 dB, it just moves over to Melbourne. We don't even know what happens; it just does it. I think we might get an email, but effectively it can just swap back and forth. And because we've got that WAN component, we never see a break in audio. So it's a break before make type switch. We don't want to dual illuminate the satellite at the same time because there'll be a few Foxtel subscribers who won't be very happy with us. But that enables us to effectively move satellites with no issue. In fact, we can bring the satellite down and it doesn't really cause any issues because we've got the WAN backup as well. Our main contribution sites to the system are our metro cities, Bunbury, Albury, Townsville and the Gold Coast. And that's a history DMG thing. That's where their hubs were. And effectively, we get their content through the iPort and across our WAN network into our Sydney and Melbourne at the same time. And basically, as we uplink from Sydney, the WAN contribution to the side of the system also comes from Sydney as well. So the WAN component is moving with the satellite. So we're not doubling our bandwidth out of Sydney or Melbourne at any one time. One of the other issues that we had is, so when we send the audio up on the satellite, we're sending all 18 channels at once. So if you've got a satellite receiver, you're getting all 18 channels all the time as a multicast RTP packet. And we didn't want to do that for the WAN because then we're effectively sending out 18 times the 78 or 38 sites across our WAN. It would max out our WAN pretty quick. So luckily through multicast and forgive me if you need me to go deeper into all this, just shout out. But we use a mechanism called IGMP, Internet Group Mapping Protocol, Management Protocol, and effectively the iPort will only subscribe to the streams that it actually requires. The satellite's a bit different; it just gets them all, and that enables us to manage our bandwidth across our WAN. A station with two services is only really going to get two multicast channels at a time. Sometimes there'll be a little bit of overlap, particularly with our sport channels, but generally only one or two. We run our premium brands HIT and Triple M at 192 kilobits AAC. We run our sport at 128 just due to the content, mainly spoken word, so we're not too worried about giving that higher bandwidth. We run bidirectional itinerants, which is a WAN-based bidirectional circuit, and that uses aptX just because of its low latency. And as well as sending the audio over, we send a bunch of control messages, now playing data, something that you would see on your car radio, bits and pieces like that as well. So this is typically a receive site setup. As you can see, everything's doubled, so we've got full redundancy at each site. That little blue box down the end is, if you don't know what that is, that's a broadcast tool switcher. We actually don't have any of those in our network anymore, so this is a little bit old. Effectively, we've removed any analog out of our stations. It's all digital, right up until it goes into the either the RF link up to the site, if it's going up as analog or composite, or if it's going digital, we actually send the multicast audio over the digital link as well. So this basically shows us that we have one audio stream from the satellite and the other audio stream from the WAN. And that gives us that full redundancy. So we've got two paths of delivery, we've got two iPorts, we've got two satellite receivers. We only have one receive dish, so I guess you could call that a single point of failure, but with the WAN, it's backed up.
How do you deal with the difference in latency between a satellite circuit and the WAN?
Yeah, so every RTP packet has a synchronization source or a sequence number. So the iPort has an internal buffer. So it'll sequence align the RTP packets as they come in, and they do come in offset, of course, because the satellite has a lot longer propagation delay. And because every packet has a sequence number, it'll pick the sequence number. Internally in the iPort, it doesn't actually know where it's getting that sequence number from. It just asks for it, and it receives it. Now, whether that comes from the satellite or the WAN, we don't actually know. It just chooses the one that's available. So when the satellite falls out of the sky, it just continues to pull that RTP packet from the WAN side, and vice versa.
And the transition is totally seamless.
Correct. Yeah. So when we do a switch, we do see loss, but only on the satellite side. In terms of the stat counters or the packet counters, we still see 100%. So yeah, as I explained, we send all 18 multicast streams through the satellite and receive them everywhere, and then our WAN side streams are received via RGMP. So as well as the audio, we send GPIO and metadata. So the metadata is really important. At the moment, we use a pretty, I would say, a little bit archaic way of signaling for ads to play in our network. We basically just send a pulse and hope that it gets to the other end, and we play the ad break, and it's the right ad break and the right length and the right hour, and you know, trust me, it can get out of sync, and when it does, it wreaks havoc on the network. We've recently just moved to a new playout system, which uses machine-to-machine language. So rather than say play an ad break, it says play this ad break from this hour. It needs to be this long, and away it goes. So what's important here is that we are able to send those messages over the satellite and the WAN, and on the receive side, it receives those messages in, and given that we have both satellite and WAN technologies, we are guaranteed that those messages will get to the end every time. More importantly is for Perth, for Brisbane in daylight savings, that data is also stored in the hard drive as well. So the data gets received live in Perth, and then 3 hours later it comes out as audio and signalling data as well.
They must be pretty big hard drives.
There are 512 solid state drive, 512 gigabyte solid state drive. So they store about 8 hours, for each channel. And that is, we can change that on the fly. We can change, obviously daylight saving every year. We have to go around and change the delay on every channel, but luckily the system just does it automatically. So we the API or the protocol used to control the iPorts is it's just ASCII, so it's pretty easy to use. And the engine, which I'm about to talk about, basically sets all out for us, and it becomes very easy.
Can I ask you, the
Yes.
audio you're storing for the delays, in fact, compressed audio?
Correct. That's right. Yeah. So it's the undecoded packets, which are then decoded back into Livewire, and then they're sent out onto effectively the AES 67.
For the people here who are not actually gurus, you might just quickly explain Livewire.
Sure. So Livewire is effectively Dante. Is another Dante, is another Ravina, is another CobraNet, is another. There's all different flavors. So Livewire is the audio over IP protocol for Axia, which is owned by the Telus Alliance. As I said before, the actual packet structure is exactly the same as every other audio over IP protocol. Their clocking mechanism is not, which is why it's not compliant with AES 67. However, their new products, you can just tick a box and suddenly they will use the PTP time precision protocol to do their clocking. So they've got their own clocking mechanism, and that was that's a Steve Church thing back from 2001 something. It's very old, not very old, but it's from a while ago, before all of the vendors got together and said we need to come together with this. They still haven't got the signaling data right. Everyone's got their own control protocols, but the actual audio can play nice with Dante and CobraNet and the like. Yes, Graham?
What sort of buffering do you have on the WAN to keep in line with the satellite services?
We have about a 20 millisecond jitter buffer. Yep. Okay. So it's pretty small. Yeah. For our bi-directional itinerants, we have it a bit bigger. Yeah. Okay. That'll ramp in and out as we need it. Yeah.
And how do you sync for real-time time announcements, broadcast to air? You don't have to worry if it's so short.
No, that's right. So when we send our network content out in the afternoon, we just send it with a gap, and everyone just knows to go at that time. So that was all that's the engineering part, and I'm happy to take many more questions if you want to really dive even further into it. But I guess, once the system's in place, it kind of just hums along. It's all, there's not even any moving parts anymore. It's all just solid state. There's no fans. It's great. The networking side looked after by the networking team. But we really wanted this to be driven by content. And that we wanted them to be able to make changes on the fly, and they didn't have to bother us with their little changes here and there. So we teamed and partnered up with ABC, who wrote basically a scheduling software which sits on top and controls all of these devices. It's kind of made up of 3 parts or 4 parts. There's the web interface, which you can see on the right there, which is a little bit closer. So there's the web interface, there's the database. So the database contains all the schedules. And then we have what we call, it's like a closed loop monitoring system. It enables us to take health checks all the way through the chain. So what we're doing is, as well as the audio and the data going up onto the satellite, we also send little heartbeat packets that contain UTC timestamps and a few little bits of information. And we receive them at every site, and we send them back to the mothership or the home base or the engine. And what that enables us to do is to make sure that we have that full closed loop from satellite, receive, and then back across the WAN. And that enables us to capture in any moment every single site and the health of that site. And that all runs within a Linux engine, or Linux operating system. It runs on a virtual machine in our Melbourne production data centre, and it has a DR to Sydney. A couple of years ago, I'm sure you heard about it, our generator failed in our Melbourne office, and we had 6 minutes on UPS. We now have an hour and a half, which is good. But I received a phone call saying, Hamish and Annie's going to air in 5 minutes. We've got 5 minutes of power left. Do something. So thankfully, our infrastructure team were basically able to engage our DR, which comes up in Sydney and looks exactly the same. And I think we got it to air by 4 o'clock, which was perfect. So, from a redundancy point of view, it worked perfectly. We had never rehearsed it. We just always spoke about it, and we just, like these things, we thought it would work. And thankfully it did.
Such faith.
Yes.
I assume DR is disaster recovery.
Correct, yeah. So basically everything comes up in Melbourne. It can be about 5 minutes out of synchronisation, but no one's making schedule changes at 5 minutes to 4 on I think was it a Friday, Gino? Thursday?
Maybe.
Yeah.
I like to forget that day.
Yeah.
Don't bet it won't happen ever.
No, that's right. Well, That's right. So I might even actually log into the work network and show you a quick overview of the engine. But effectively, it kind of looks like an Outlook template. There's two sides to the scheduler. There's this sort of the uplinking side, and then there's the receiving side. So the contribution side, I should call it, is mainly out of our metro cities and those hubs that I mentioned before. And effectively, the person in control of the operations for that basically it's like a TiVo. So they put all the shows in their time blocks. So here we can see 11 to 12. We've got Alan Jones coming out of Albury. And basically they put it up on the bird available for anyone to take. And then all the receive stations can choose whatever shows they want, whether it be they don't have to take Alan Jones. They can look at taking the local work show afterwards at 12. And effectively, it just works like an EPG guide for a TV or a Foxtel, but for audio. And as well as when they select that, it also marries up all the audio, all the data. If you're in a time zone delay market, it'll take note of when you actually want to receive the show. So, you know, if you're in Perth, you want to receive the show at 4 o'clock Perth time, not 1 o'clock Eastern Standard Time. And it does all that for you, which is fantastic.
Actually, that's an interesting point. So that's coming from Sydney, from Macquarie.
Yes.
As a regional syndicated program into the Albury hub.
Yes.
By satellite from Sydney?
It used to, not anymore. So now my good friend Bill Barrington allowed me to install one of these into the Macquarie Media Syndication data centre. So we use the DVN network, or the Digital Video Network, which is a Telstra product. We put data across that now rather than video, and we have one of these sitting in the Macquarie Media data centre, and effectively someone in Albury does the booking, and at 9 a.m. every morning, Mr. Hadley goes live to air, and it comes straight out of Macquarie, across the link to Sydney and Melbourne, and straight up the satellite. And the reason we did that is we just had, again, too many kinks in the chain that could go wrong. We wanted to make sure, we owed it to our affiliates to put Ray to air and the Macquarie shows. So we needed to make sure that we could get that to air. And we found doing it the way we're doing it wasn't working. So we just said, let's just put one in their data center. In fact, they already actually had one, because in the reverse, we provide content to affiliates as well. So at the Macquarie Media Centre, they receive a lot of our shows, Hit Network and Triple M Network, and they actually put them back up on the Fairfax satellite, or the Macquarie satellite, or whatever it is now. It just changes name so often. I think it's about to come the 9 satellite. So I guess, what's important is that we've set up a distribution system for the future. We've already grown the system. Initially, we had 2 megabits on the satellite. We recently signed a deal with Optus. Now we've got 3 megabits, which has allowed us to increase a lot and get more channels as the business grows and the needs grow, particularly with DAB and online streaming and things like that. Excellent audio quality, of course, using the AEC codecs. And dual path delivery. So we've never had that issue where we've lost both paths at the same time. We get the sun transients every year for about a week, and we never see any issues because of that WAN. In summary, it was very good working on this system. As I said, I was one of the lead systems engineers on this project. My main job in the beginning was to create do all the PLC code for the satellite switching. But in the end, I've been fortunate enough to take a really deep dive, even at a code level, to see how all the system works, which is really, really great. It's a really great system. I've got some pictures here. This is the satellite dish being installed into Melbourne. Very tight, just up the road here. And you'll like this. So before this was all just because this was a greenfield system, we needed to make sure it would work. So we actually built the whole system in Adelaide, and here's a picture of it here. So that's We called that the Frankenstein. So that's every site. I tell you what, I don't know how many cuts of firmware we had for those devices, but it was a very manual process to go and update every single one of those. It wasn't easy. And that's it for me. Now, question time, if there is any. Yes, Graham? Great.
First thing is, using AAC, which is lossy encoding, you've never done lossless encoding for the audio distribution, primary audio distribution?
No, so you're talking like FLAC, things like that?
AAC is not lossy. It is lossy.
It is lossy, yeah.
So ALAC, FLAC, WAV, whatever.
Yeah, oh, well, linear, or WAV, we just don't have the bandwidth.
No, you've got to compress.
Yeah, so three megabits on the satellite doesn't give us much.
No.
FLAC, look, if FLAC was available, I'm sure we would probably look at it. But at the time, the iPorts are linear, of course. Yeah. And I actually have a great story to tell you about what the BBC have done, which is quite interesting with these products as well. They do MP3, MP2, a whole bunch of AAC, every flavour, and aptX as well. And there, of course, there's licensing conditions. So if you don't want aptX, you don't pay for it. If you want aptX, you pay for it.
The broadcaster radio is about sound with accompanying pictures. Are you video ready?
Yes and no. Not over the satellite, that's for sure. But so if we can use DAB as an example, particularly the slideshows and things like that, we haven't centralized that play out, so it's a distributed model. So we, as it plays out from Sydney, Melbourne, Perth, Adelaide, wherever we've got DAB, the pictures and the data are housed in that market. Obviously as a media company where we've got lots of social media channels where we put a lot of our video content. So certainly, if you walk into a radio studio today, it doesn't look like it used to. There's no the big tannoys are not there anymore. They're just these little tiny things because they get in the way of the cameras and the lighting, and yeah, it's like a TV studio now. It really is.
What was so unique about this particular system? You seem to imply at the beginning that there was something that hadn't been done before in any other country. Is that the geographical distribution of Australia, or
I think
systems you had to connect?
Yeah, so there's certainly other distribution systems, but it was the difference in time zones, and the fact that a lot of particularly in the US, it's centralized play out for them. So they'll have a data center that plays out everything. For us, every single station has a breakfast show, so there's studios locally, and they'll be local from 6 till 9. Then they might do a day show, but then they might take the satellite or they might not. And it was different in every single market. So that was a really unique case. And on top of that, sporting, SCA, we have the AFL rights, we have the NRL rights. So we needed the ability to switch in and out of time zone because, of course, delaying the football is a waste of time because no one will want to listen to it. So we needed the ability to adapt on the fly.
And I assume the other unique feature is that you've got the one studio audio override through protocol across the whole network.
Yeah, so
that would be pretty unique.
Yes, so we, our ability to interrogate these systems now remotely is something that we never used to be able to do. We can listen to any single audio source anywhere because it's all IP. And one of the key features, I think one of the driving factors here is that we only encode and decode once. That's it. There's no duplication. There's no decoding and coding like we had before. One of the main issues, once we built this system, we put it live, we went, great. Where are the single points of failure? We did another test, and we found that particularly in our main contributing markets, for example, Brisbane or Adelaide or Perth, their only connection to the system was WAN. Pardon? Yeah, so if I'm in Bunbury, they send out quite a few shows. Their only connection to the SCASat system is via the WAN. They send it to Sydney and Melbourne, and then they uplink it. The problem is, if the WAN gets cut between here and Bunbury, what do? So version 2 of SCASat sees us use a very small slither of bandwidth in Bunbury, Albury, Gold Coast in Townsville and Newcastle. And it's about a 384 kilobit bandwidth, and we send the program back up onto the bird and receive that back down in Sydney and Melbourne and turn the data around and send it back up. So if we ever have an issue where the WAN gets cut between those markets, and we've had to use it in Bunbury a couple of times, we can just flick a switch and it suddenly starts receiving it off the bird, grabs that multicast data, and then ships it back up the bird. So we're covered there. Yes?
How about security? How have you segregated that from the public?
So we don't encrypt the streams at all. You could effectively just, if you really wanted to, you could buy this receiver and you could spend a lot of money on one of these, and you could listen to our streams if you wanted to.
Could I modify your streams?
Could you modify our streams? Well, you can receive the audio and do what you would like with it, but you can't modify the uplink stream because it's all internal to our network.
Do you mean like a man in the middle?
Yeah.
Well, given it's not encrypted, I guess you could, but
you couldn't act as a man in the middle unless you were to insert yourself to our WAN.
Yeah.
In terms of modifying the satellite stream, it's impossible without double illuminating the bird, and then you'll just blow all the data off it anyway.
Realistically, wouldn't you just be on that satellite receiver hearing the same audio that's being transmitted via an FM or a DAB in the region anyway?
Yeah, there's nothing that goes across there that doesn't go to air. You might hear it 3 hours earlier, but you can go you can go on the internet and listen to the Melbourne stream now anyway. So,
Betting on football.
You mentioned you were going to talk about how the BBC reacted.
So the BBC have taken it a little bit further. They've decided to centralise basically everything, but still have the edge studios, and they called it the Vylor project. Stands for virtual. Ian, help me out.
Local, keep going.
Virtual something local.
Virtual local radio, basically.
Yeah. And what they've done is they've worked out that if they don't put data centres in every single one of their studios and put it all back into 2 main metro data centres, they can save a lot of money on cooling and power, etc., etc. So what they've done is they've used iPorts, except they're using them with linear. And they basically have the linear iPort in their studio, and that basically sends linear audio back to the data center, and the data center sends it back. They have localized monitoring in the studio, but all the DSP, all the mixing, all the play out is done in a data center 100 miles away. They have 2 of the data centers, and basically they worked out if they did that to every single site, they could save a lot of money on cooling and power. They spent a little bit more money. What they were able to do, because inside here is effectively an Advantech motherboard, and they worked with Telos in manipulating them so they could put them vertically and in a slotted array. So I think they can get 12 across a 5RU space. So here we've obviously got 2RU and that's it. So they could do 12 in 5RU, and they basically just built this giant data center, 2 of them, and they effectively do all their mixing and DSP work at the data centers, and they have localized monitoring in their studios. So it's a very unique way of doing it.
And you should talk about the fact that it took them 15 years to upgrade their 52 sites, and now they can do it overnight. That's one of the biggest. It's like painting a bridge.
Yeah.
By the time they've got halfway around in the gear, it's already too old.
That's it. Yeah. And any other questions?
You said earlier that you'd be able to log into the scheduler?
Yes. Let's see how easy that will be. Is there any Wi-Fi here? So the landing page is more of an engineering type page, so it allows us to work out who's uplinking at the moment. So we can see that Sydney is uplinking, and the way we do that is in Sydney and Melbourne, we have dual modulators or satellite encapsulators where we turn the RTP multicast data into RF effectively, or a DVB-S2 signal. That feeds into an up converter. Well, it feeds into two. So we have two encapsulators, two up converters. We've got one dish, but we've got another one in Sydney and Melbourne, or in Melbourne. Each one of those encapsulators gets a little of its own UTC data packet with its own little unique message. And because only one encapsulator's on and only one satellite's on, we only ever receive one message at a time. So we're able to pull out of that UTC or that UDP message where it's coming from and some UTC data and things like that. We also do a whole bunch of monitoring on the tasks that run in the background, the processes. And then we can have a look here at all of our station sites. So we also provide to Sunshine Broadcasters in Maroochydore, so we're connected to their system. In Adelaide, we can have a look at what our satellite receivers are doing, what our iPorts are doing. So we've got a full overview of the system. I will log into this as well. As well as that, we have a pretty... So this is basically the control center for the uplink. So you can see we've got dual modulators, dual up converters, dual sites. The beacon receiver is what we use to determine the attenuation between the known power output of the transponder on Optus D2 and both the Sydney and Melbourne site. We do pretty comprehensive trending of all of our sites as well. So we've got, I think, 114 satellite receivers out there, so we can actually take a... And what's cool here is you can actually see the earth wobble as part of the signal there. So you can see that kind of sidal wave there. That happens every 12 hours. Obviously, I think that's Albany. I think they must be getting an absolute dumping of rain. Yep. So yeah, we trend every single satellite receiver so we can... If someone calls up and goes, oh, you know, we had an alarm go off, etc., we can usually tell what's going on. And then basically, if I'm a content user, I log in and I go, well, I want to book a schedule for the HIT network. And they're pretty static, so you can create templates and just go Monday to Tuesday, Monday to Friday, just dump it in there. So effectively, they just create a book. They create a booking. We tell the system where it needs to come from, and the engine takes care of the rest. What's really cool is once we built this system, we went up. I think it was Hamish and Andy. We went to Hamish and Andy. We built this great system. It's fantastic. You'll love it, but you just need to finish your show at 6 o'clock. And they said, no, we're not doing that. We want to finish at 5:55 or 6:15. We want to finish when we want to finish, not when you tell us to. So that was a bit of a problem for us because this is purely a time-based system. So it wasn't going to work. So we had to come up with what we called the floating endpoint, which is what we're seeing right there. So it enables us to overlap bookings, and effectively our playout system sends a message to the SCASat system when we should change schedule. So at any given time, and obviously there's only that much of a window. What's that, 10 minutes? So we've got a 10-minute window. Any time in there, they can fire off this message. And basically what it does is it changes a priority. So we have a priority setting from -5 being the least to +5 being the most. So you can see here, we've got a -5, which means that one's already been fired, which was this morning. But if we head down to, what's the time, 8:47. So we can see here, this booking is current. It has a little lock on it. And it has a priority of 4. When the message goes out at 10 o'clock tonight, that'll go back to -5 and the next schedule will take over. That only really happens with the HIT network. We don't have that problem anywhere else. So that was an interesting one.
You talked about the security on the program feeds and said you really don't need it. But you've just logged into the actual control system there that allows you to have access to the whole network.
Yes, but I also VPN'd in with my own AD credentials.
Okay. Yeah.
This is not public.
No.
So it's fully secure.
Yeah. Yeah. You didn't see the Juniper Pulse login.
Ultra VNC.
No. Well, we without going into the company's secrets, we use a pretty robust VPN. Yeah.
No worries.
So yeah, I've logged in to our company VPN. You can't get to it any other way. Yeah.
Great.
And then that's the uplink side. And then if you want to book a show for, I don't know, let's choose one here. Rockhampton Local Works Network Receive. You can either do two things. You can pick and choose all the programs you want, or you can just say, give me all of it, and I'll choose when I put it to air, which is what most people do, because it takes that extra bit of work out every week from the content operators. Yes, Graham?
Sorry, lots of questions.
Yeah, that's right.
With this flexible scheduling, how do you manage auditing advertising?
That's all done using the playout system. So the playout system will reconcile back to the traffic system, and that's how we're able to work out what went and what didn't go to where.
Okay, so you can actually report to the advertiser.
Yeah, so we actually, when we are doing a network show, we don't actually send out any advertising at all. It's just gaps of silence, and it's all played out locally. So every day or whenever it is, the playout system will send a reconcile log back to the traffic system, and it will say
This is what we put in.
either it played or it didn't, and here's why it didn't. Yeah.
You just mentioned each other network sites, choosing with them pretty shows where. Where is that being stored and buffered?
In a database.
Sorry,
The audio?
locally at the site.
Yep. So it's always coming out in the audio world. It's going into the IP switch, and it's just floating around as IP data. Whether they actually switch that to program is completely up to them.
Or they can basically do a store and forward exercise.
If they want to receive it in 3 hours' time, because they're in a different time zone, it'll actually be on the device. 3 hours later, it'll come out. We've got two in every site, like I said. So if that one it dies, because they are prone, once in a while to lock up or do something they're not supposed to, we just switch to the other one, and that was also storing 3 hours worth of content at the same time. So yes.
With the redevelopment and the infrastructure you have to put in place to equalise each particular port in Australia, what was the actual hardware cost to actually achieve this?
That is a good question, and I didn't see any of the financials, so I could only guess. That's it. I know from an operational cost, keeping up the old system was pretty expensive, and using the old. Oh.
You'll know.
Close out of that. The old system was pretty expensive. We used, I can't remember their name. It's an IDC product, and operationally that wasn't very cost efficient. And given all the problems we had, the lack of redundancy, all the single points of failure. Having only 2 channels, now we have 18. The content capabilities have been exponential. So,
But would it also
give us an
been,
estimate?
would it have been part of a general capital upgrade of the studio equipment?
So we did the whole country at the same time. So it wasn't a staggered approach. We just went, everyone gets the same equipment, whether you're in Katanning in the middle of nowhere where you've got no one in your building, or Sydney, Melbourne on the big sites. I wouldn't even know what the cost was. I would say more than $1 million. I would say. That's the diplomatic answer.
So who did the physical build both in Adelaide when you set up to test it and
Yes.
deploying out to the sites with your own staff?
Yes, yeah. So in Adelaide, we had Steve Adler was in the Adelaide office, so he ran the Adelaide. He's not the manager of the engineering team, but he had the engineering team at his disposal. There's about 5 or 6 people. We also had our networking expert Rob Tuck in Adelaide, which really, really helped, because the audio bit's easy. It's the networking part that was really, really difficult. And he has a great relationship with Telstra. which enabled us to get the next IP product, which is effectively a meshed WAN system. So every single site looks like it's one hop away, not routing through 100 different sites. So to us, it just looks like it's from Sydney to Katanning, done, not Sydney to Bunbury to Perth to Katanning. So that certainly helped. That was a big job setting up that system. We had engineers flying in from Melbourne. We had engineers flying in from Perth. We had engineers at AVC remotely logging in from all parts of the country, of the world, sorry. It was a massive collaborative effort between not only the radio engineers, but all the technology, IT staff as well. And yeah, someone had to pack those back up into boxes and ship them out, which was a big effort. And effectively, when it got to site, it was, we're only talking about 4 or 5 things. Put it in a rack. It's got 2 network plugs on the back. Done.
So pre-assembled and shipped out.
Pretty much, yeah. Yeah.
How long did the whole project take?
It started in 2012. It was supposed to go for about a year. It went for about 2. So they finally got to a point where they were happy with the firmware in the iPort and all the little bits and pieces in between.
How about looking towards the future? How far do you think you can push the system before you need to think about changing course again?
Yeah, so every year we get funding to develop and build a better system. We sit down with content and see if their needs have changed and their content, so they have. And we, as an engineering team, we also sit down and go, what could we do better? One of the biggest problems we've had is because it's a time-based system with to a degree, we have bi-directional itinerant lines which run on aptX, which allow us to do interviews with every other studio in the network. So when we have, a famous person in Sydney, they can effectively do interviews with every single person. The problem is, if you set that up as a time-based booking and then the guy is 10 minutes late, it becomes very difficult to try and shuffle all of those schedules again. So we're working with the manufacturer, AVC, and working on a better system for that. We're always looking to build a better, more redundant, more robust system. So we're looking at high availability models. How do we increase that recovery time from, a DR of 15 to 20 minutes to 2 minutes and things like that. I guess at the moment we're kind of semi-limited to what we can get on the satellite, being 3 megabits. We can put probably as much as we want over the WAN, but we're certainly seeing an enhancement with WAN technologies. Given our relationship with Telstra, we're seeing where we once had a couple of megabits into that market, we now have 20, 30, 40 megabits. So that sort of opens up what we could do with that market. I haven't had any questions from my engineering team in Melbourne.
Dan, I've got a question about UPS. You mentioned you extended from 6 minutes to an hour and a half.
Yes.
Did you do that just with battery storage or also gensets?
No, just battery storage. Yeah, so effectively 6 minutes is enough time if your generator starts.
Yeah.
But when your generator blows up the batteries, it becomes a bit more difficult.
Yeah.
My interest is in training, and you've mentioned that you've got IP-type engineers or computer engineers.
Yes.
You've got audio engineers.
Yes.
I presume that they are trained with a degree or...
Yeah, so one of the courses that we kind of look at now is the Cisco CCNA, which is sort of an entry-level Cisco course, because, as I said before, it's less about the audio now, more about that networking side. The audio part, particularly in our sites that are newer sites, we don't have any analog. The only analog audio is the microphone and the speakers. That's it. Everything else is digital, and it's digital all the way up into the transmit until you receive it back on your receiver.
The transmitters, are they radio engineers?
Yes.
Old school?
Yeah. It obviously there's, that's one problem we're addressing now with the CRA in terms of what skill set we need in the future, and RF engineers is certainly becoming more and more difficult, given they hardly even teach it in school anymore. So it's becoming more and more difficult. That's it. Great. I can keep going.
Do you want to show us the iPort?
Sure.
Make it listen in on the stream.
So who's this? This is Newcastle.
Oh, mate, that's the other chapter. That's good.
So it's nothing really special. It's 16 codecs. The top line is the send, or the encoder. The bottom line is the decoder. If you can dive deeper into the product and you can set a whole bunch of other parameters, but generally we just look at the statistics page. We can see here that on packets A, that is our WAN. Packets B is our satellite. The reason why we've got 200% is because we've got 2 satellite receivers both flooding in packets at the same time, and that gives us an output of 100. So, you know, if we were to pull the cable on the WAN in Newcastle now, nothing would happen. That would stay on the air. And then I'll take it one more step. So now we have the ability, if we want to, we can go into Newcastle and we can actually listen to this device if we want to. That's net 2, it's not going to have anything.
Spin for Kids in Newcastle on September 7. Register at variety.org.au. Kid 106.9.
So that's
Liquid ceilings are also the norm when you build with us.
the fact we can listen to the microphone in the studio. Like, that's the kind of granularity we have now. And that enables us to effectively manage any site from anywhere, which has really helped in the IP world. And we've just finished rolling out our new playout system, which gives us a flat footprint in terms of the same distribution equipment, the same playout system, whereas before, through various mergers and acquisitions, we had 85 flavours of the same thing, which made it very difficult to manage. So
you see yourself going the same way as BBC, decentralising?
Yeah, look, I think SCA, what's really important, SCA is our localism. So we would never pull off the radio show, the breakfast show from Warragul or wherever. In fact, we're about to move. Historically, we had hit Bundaberg out of Townsville, and we're building a new facility in Bundaberg. It's due to go live in a couple of weeks, just because we wanted to be local in that market, not from Townsville. It just didn't make any sense. And, you know, from a listener point of view, it's just no good. So, yeah, look, the BBC thing is interesting. I think the BBC have a great R&D team and budget, given that everyone has to pay for their TV over there. And I think they've got fatter pipes into every market, into every site in terms of their WAN capability, whereas we probably aren't there yet. And I dare use the word NBN Co.
I've been NBN of you. More questions? Now's your chance.
Dan, do you see an opportunity for perhaps in some way promoting your solution offshore? Like
Yeah, so we don't.
sense to maybe CBC or
Yeah. So we don't own.
similar geography.
Yeah.
Issues.
Yeah, so I've done this presentation to Scott Radio in Canada. They have exactly the same criteria as us. They have a massive they've got a lot of geographic diversity. They've got different time zones. It's basically a mirror image of what we do here. Yeah. SCA doesn't own the IP for this. It's owned by Telos and AVC. Yeah. So, you know, for us, we want everyone to have this product because it only prolongs the life. It obviously it fosters a creative, innovative environment where they might think of something we haven't thought of yet, and we can take advantage of that.
Many years ago, I sat in a seminar that had Pacific Islanders here talking about the communication facilities, and what you've just shown tonight would be absolutely ideal for Fiji and places like that is distributed on many islands.
Yeah, definitely.
Dan,
Yes, Ian.
I might ask that if I could. So ABC owns a company in Fiji, has built their latest digital television service there.
Yeah, so they've got a presence there.
We've got a lot of interest there about sharing content between islands. A lot of media companies are spread around too, so I from an ownership perspective.
Yeah.
Questions? Okay, Dan.
That's
Thank
it.
you very, very much.
Thank you.